So I'm not going to do all the notes today. We're going to do some of them today. We're going to finish up on Monday. So geometric sequences, that's what we're dealing with today. We did arithmetic last time we were together. We'll start the geometric sequences today. They have a common ratio, R, that's what you're multiplying by each time. Remember, with arithmetic, you're constantly adding. With geometric, you're always multiplying. So even though you may think about dividing from one to the next, how do I convert that division to multiplication? So dividing by 2 is the same thing as multiplying by 1/2. Geometric means missing terms between two other terms in the sequence, just like arithmetic means, same idea. We have here's a number, and we have spaces between we're going to fill. Same idea, a little more difficult in how you do it. Part of the reason why this lesson takes longer is the math involved or the arithmetic involved is more difficult. Geometric sequence formula. I mean, if you look at this, it's a more difficult formula. You have exponents on it. Okay? So the nth term, a sub n, is equal to the first term, a sub r, times r, the common ratio, to the n minus 1 power. Okay? And you have to do this in your calculators. I mean, some of them might be simple enough to do by hand, but basically, no. There's going to be stuff you're going to do on your calculator, and you're going to be doing fractions on your calculators. Know the fraction key on your calculators. You have a fraction key. Usually, I believe that's what it looks like. Okay? I know on mine it does, on yours it does. You can do everything you can do with any other number you can do with a fraction, and it will give you fractional answers, which is what I want. So what you do is, let's say I want to do 1/2. I type in 1, I hit the fraction key, I type in 2, and it shows up on your calculators 1/2. Okay? If you want to do a mixed number, you just hit it twice between them. It's like 3.5, I put in 3, hit that, put in 1, hit that, put in 2, and it gives me 3.5. And it's got a little L-shaped thing that separates the two numbers for your fraction, the numerator and denominator. And if it's a mixed number, it's the whole number, the numerator and the denominator. And you can actually, I think on those, most of you can actually go back and forth between mixed numbers and improper fractions. There's a little shift, and I think the one above it, that when you hit shift, what's above it will actually swap back and forth between improper and mixed numbers. So let me do that for you. You should know how to use them. And we're going to be doing that. So we're going to work with fractions. You'll want to have that button if you want to use the fractions if you want fractional answers, not decimal answers. If your original problem is in decimals, decimals are fine. If your original problem is in fractions, you better have fractions. Okay? Any questions? Okay, so let's do this. First of all, determine if the following are geometric. If so, find R. So we do the same thing that we did with the arithmetic. If you look at it, sometimes it's easy to tell. How do I get from one to the next? How do I get to one to the next? How do I get from one to the next? And sometimes it's easy to see. Sometimes it's not. This one here, it's not easy to tell because I've got a bunch of fractions that are getting goofy on me in a hurry. So with the addition one, we took a number and subtracted the one before. With geometric, you take a number and you divide by the one before. So I take 9 and divide it by 6. And I get 1.5. Now, I'm okay to have decimals here because I have decimals already as part of my work. The next problem has fractions. I need to have fractions, not decimals. Okay? But I want to make sure, so I do it again. 13.5 divided by 9, and I get 1.5, and I should really do 20.25 and divide that by 13.5, and yeah, I would get the same thing. If you get the same number each time you divide, it is geometric, and my R is that number. Okay. Arithmetic, you subtract. Geometric, you divide. Kind of that way. There's a very close relationship between the two. Arithmetic, you add. Geometric, you multiply. Arithmetic, you subtract. Geometric, you divide. There's a connection between them. So the next one, I want to do the same thing. Now, there's kind of a little bit of a hint here of what it is. What do I multiply 3 by to get 3/4? I multiply times 1/4. So I'm kind of thinking that would be what I would do. If I want to check, I do that. Now, I don't want a decimal because I have fractions. But I can take 3/12, and if you reduce 3/12, what do you get? You get 1/4. Now, if I take 3/4 and divide that by 3, do that on the calculator using your fraction key. Type in, hit 3, fraction button 4, and then divide that by 3. And what do you get? You get the fraction 1/4. So you get your fractions. 3 divided by 12. So you end up getting 1/4. So this is geometric. And R equals 1/4. So I'm dividing by 4 every time, which is multiplying by 1/4. That's what I want to think about that as. Next one, is this geometric, yes or no? Yeah, what's my R? -1. This is one of my favorites. It's also one of the easiest. So yes, this is geometric. R is -1 because I'm changing sign every time. This is a recursive formula, not explicit. So I start with 2 as my first term. How do I find the next term? What do I do to 2 to find the next term? I multiply by -3. How do I find the next term? Multiply by -3. How do I find the next term? Multiply by -3. I am multiplying by -3 each time. This is geometric, yes. And R equals -3. If I have to take the number I have and multiply it by the same thing each time, that means I have a geometric one, and that thing I'm multiplying by is my R. Okay? Your turn to do those. All right, so let's do this. So the first one, is this geometric? No, it's actually arithmetic, but it just says geometric, yes or no, and this one is a no. We're actually subtracting 5 each time. We're not multiplying by the same one each time. Second one, arithmetic or geometric, or sorry, is it geometric, yes or no?
Geometric.
Yes, it is. It's geometric. 0.4. And R is 0.4. I prefer not putting the 0 in front because sometimes people get confused, but it doesn't really matter if you do or not. Yeah, it doesn't really matter. Yes, that one is. It's okay to have it be a decimal and not a fraction because you have decimals in there already. Okay. This next one, yes or no? Because I'm not just multiplying by 2, I'm also adding 3 each time. And if you're not sure, generate a few numbers and see if you get the same thing. So the first number is -1. Second number, I take -1 times 2 and add 3, and I end up getting 1. And then I take 2 and add 3, and I get 5. And that's not geometric, because geometric, to go from -1 to 1, I'd multiply by -1. -1 times 1 does not give me 5. And neither is this arithmetic either. No, it's not. If you recognize, if it was just the multiplication, then it would be a geometric. If you have multiplication and something else, it's not. Okay? So if you have multiplication and something else, it's not going to be geometric. But if you're not sure, generate a couple of numbers. Hey, we're good. It's not. It could be, but it's not either, because you add 2 and then you add 3, add 4. So yeah, no, it isn't. So this one here, yes or no? This one's also a no, but this one is arithmetic, because all I'm doing is subtracting 4. So I'm going down by 4 each time. My D would be -4, but this is no, it's not geometric. Okay? So to be geometric from an explicit formula, or sorry, not explicit, a recursive formula, it has to be just multiplying to get the next one. For it to be arithmetic, it has to be just adding or subtracting it to get the next one. No multiplication involved. Only addition or subtraction, only multiplication. That's geo and arithmetic ways of recognizing it. Okay, so now we're going to go, and this is where it's going to get nasty. We're going to have to use this formula here. Your calculator will be huge on this one because you've got exponents. Okay, so I need 3. I have, once again, this formula has 4 things just like the arithmetic one we did on Tuesday.
Oh, that's great.
This is my nth term, this is my first term, this is my ratio. That's what term number I'm dealing with. So I want to find a sub 9. So my first term is 3/8. I need to find my R. My N is 9 because I'm looking for the 9th term. I need to find my R. Okay, what am I multiplying by each time? So to go from 3/8 to -3/4, I know my R is going to be negative. And to find out for sure, take -3/4, divide it by 3/8 and see what you get. And that's the easy way to do that. You got a calculator that will do that for you. 3 fraction 4 divided by 3 fraction 8. And yeah, you get 2 and you get -2. So my R is -2. It's not bad. When your R is a fraction, that sucks. When your R is a decimal or a whole number, it makes it a little easier, but you do have to watch your negatives and positives. Okay? So I set up the formula. A sub n, or a sub 9 in this case, a sub 9 is equal to my first term, 3/8, times R, which is -2, to the n minus 1 power, 9 minus 1 power. Notice I just plug my numbers in. It's particularly very easy to go, oh, that's to the 8th power. When I calculate it, I'm going to use the 8th power. But when I write my formula down, I don't. Okay, I put it to the 9 minus 1 so I can keep that formula straight in my head, what it's supposed to be. It's n minus 1. That's what my exponent is. So now you type that in your calculator and you do it. And here's how I do it. I don't do it all at once. I take -2 and I put it in with parentheses around the -2. Okay, -2, put parentheses around it, and then I use my little caret key, which is the exponent key. And I could put parentheses 9 minus 1, but really 9 minus 1 is 8. So I take -2 to the 8th power, and then I multiply that times 3/8 using my fraction key. And the 9th term is 96. And if you don't put parentheses around the negative, your answer will be -96. If you don't put parentheses around the -2, your answer will be negative when it should be positive. And so you have to watch that, because if you have a negative R, every other term is going to change sign, and you need to know which one it should be, and you need to get it correct. An even power will make it positive, and odd power will make it negative. You gotta watch that. That's why I said I put parentheses around there. Okay. So here's another one. This one's a little more difficult to do for one particular reason. Same idea though. My first term is 5. That's nice to have a whole number. I'm going to come back to my R. My N is 10. I need to find R. Now, once again, I can just take 5/3 and divide it by 5. That will work. My R is 5/3 divided by 5. But if I have 5/3, I have a third and a third and a third and a third, and I have 5 of those, and I divide that by 5, how much is one of those 5 objects I have? It's 1/3. And think about it. How do I go from 5 to 5/3? What do I multiply this by? I multiply it by 1/3. Okay, so my R ends up being 1/3. And yes, it has to be fractions, not decimals, because we have fractions in there. If you give me decimals, you're going to give me an answer that's inaccurate. I will get an exact answer with fractions. And you can do fractional powers on your calculator. So I'm looking for the 10th term, a sub 10. It's equal to 5 times 1/3 to the 10 minus 1 power. Now, your calculators sometimes will freak out on the fractions for this. Let's see if it does on this one or not. Because I'll show you how to do it if it doesn't. Okay? Because some do, some don't. And I'm not sure if mine will or not. Like I said, an extra $40 should buy me a little bit more, but sometimes it doesn't. Okay? This is a graphing calculator. It's $50, which is the cheapest graphing calculator you can buy, but it does absolutely everything I need and then some. So why spend $200 on something when $50 will do what I need? Well, the $200 buy you, it'll buy you color. And a couple of extra little things that really aren't necessary. So, and I actually do have more expensive ones because I want to have some examples if I can of what some of the kids use and other stuff. But I can still use this all the time. Okay, so let's see. I'm going to take 1/3 to the 10 minus 1. That's the 9th power. Oh, no, mine gives it to me exactly. I got 1 over 19,683 when I did the 1/3 part.
What a number.
I did not multiply that times 5. Now, so here's, and I multiply that times 5. A sub 10 is 5 over 19,683.
So if we have it as a decimal.
No. No. And here's what I want you to do, and I'm glad this kind of happened that your calculators weren't doing it, because here's what you can do. Here's what you can do. This is 5 times 1 to the 9th power over 3 to the 9th power. Right? Because what's a fraction to a power? It's the numerator over the denominator, which gives me 5 times 1 over 3 to the 9th. And your calculator will do 3 to the 9th. And you'll get 19,683. But that's what you can do, is you can do, if your calculator freaks out because it's really big and says, screw you, I'm not doing a fraction, we're doing a decimal. Okay? This is what you can do. Did you get that? Oh, okay, I know what's going on. Yeah. So, but don't do 1 over that. Do 3 to the 9th by itself to compute the denominator by itself. Do you see what I'm saying here? I'm saying do this number, just the denominator on your calculator. Okay, and if your numerator was something other than 1, let's say it was 2/3, do 2 to the 9th power on your calculator, do 3 to the 9th power on your calculator, write down those two numbers. Because you can do it in parts. You don't have to try to do the whole thing at once. Okay, does that make sense? So you can do one. You got 1. Figure out what 3 to the 9th is on your calculator. 3 to the 9th is 19,683. And then 5 times that gives me my 5 in my numerator. Okay? That's what you can do. You can do this as a fraction rather than a decimal by being smarter than your calculator. Okay. Yeah, mine did it. I wasn't sure if yours would do something that big or not. Most of the time it's not bad, but every once in a while you're going to run into hiccups like that. Most of the stuff comes out okay. And remember yesterday, I had you find the 77th term and the 23rd term, and you will never have a term number that large with this, because when you get geometric, they get nasty ugly. They get tremendously huge or tremendously small. Okay. So do these two. Yeah, an 11 or 12 is about the absolute largest you will ever get. Okay, let's go ahead and do these. Excuse me. So my first term is 4. My R is -3. And my N is 8. I'm looking for the 8th term. Okay. So A sub 8, 4, -3, parentheses around it, to the 8 minus 1. And I do write N minus 1, whatever N is, minus 1. I always just plug the numbers in the formula. I don't simplify it until I'm actually doing the formula, because the formulas do change. And whether it's an N power or N minus 1 power, you need to be able to handle that. Once again, put parentheses around it. -3 to the 7th power times 4. And I get the 8th term is -8,748. And you do have to watch the negatives and positives. So this one, find the 11th term. The first term is -2/27. R in this case is +3. And N is 11. So A sub 11 is -2/27 times 3 to the 11 minus 1 power. A sub 11, -2/27 times 3 to the 10th, 59,049. 59,049. And then I multiply that times -2/27. Now, you can put it in as a fraction, or you can multiply it times 2 and then divide by 27, because it's just the fraction times a whole number. Either one will get you the correct answer. Times -2. And you get -4,374. Okay. Questions? Okay. Not pretty. We're going to come back to this. And we're going to skip this one too, because those are those. And we're going to go and find our geometric means. Geometric means. So we're still looking for the same thing. I have 5, and I'm looking for 1, 2, 3 numbers between 5 and 80. I'm looking for 3 numbers between 5 and 80. Now, this is where it gets fun. Yeah, because remember with the arithmetic, what did we do? We took the last number minus the first number and then divided it by how many spaces were in between, right? So we're looking for R, which we're going to take 80, divide it by 5 instead of doing the subtraction. Now, Here's where it's tricky. Instead of dividing that number, we're going to take the fourth root of that number. 1, 2, 3, 4 times to get through there. The number spaces plus 1. So you have to do the fourth root on your calculator. You have a root button key. It usually looks something like that. That's your root button key. You type in the roots, and then you type in what's underneath. Now, if you're typing it in all at once, hit 4, hit the root button, parentheses, 80 divided by 5.
Wait, 4?
Because you're doing the fourth root. 80 divided, put parentheses around the 80 divided by 5. Because if you don't, it's going to take the fourth root of 80 and then divide that number by 5. Okay, your calculator does exactly what you tell it to do. It follows order of operations to the letter. And it will do the fourth root of 80 and then take that number divided by 5 unless you put parentheses around the 80 divided by 5. And I do believe, I think it's 2 is what you get. Yeah. Because 80 divided by 5 is 16, and the fourth root of 16 is 2. I've been doing this long enough, I know some of these numbers off the top of my head. I don't expect you to know all of these numbers off the top of your head. Okay. So yeah, I get 80 divided by 5 is 2, so that means I have to multiply by 2 each time. So that gives me 10, 20, 40, and then if I did it again, would I get 80? Yeah, I would. Okay? Does that make sense? Next one's a little more difficult. The concept is the same. I have 64, and then 1, 2, 3 spaces, and then 4. Which means I'm going to have fractions. So my R is, once again, because I got 3 spaces, the fourth root of 4 over 64. Now, I prefer exact, not decimals. I want a fraction for this. Use your fraction key for the 4 over 64. By the way, type in 4 over 64 as a fraction first and see what happens. What does it do? Just don't take the root, just do 4 over 64 as a fraction. What do you get? You get 1/16. It automatically reduces your fraction. So if you want to reduce fractions, your calculator will reduce fractions for you. If they're reducible, it will reduce your fractions for you.
What a nice guy.
Okay, I mean, hey, you should know how to do it by hand, but it's nice to know that you have a tool that can do it for you, particularly sometimes, you're taking a test, you're having a bad day, whatever, your brain's having a little slow working. Hey, let your calculator do the heavy lifting. So this is actually the fourth root of 1/16, which is 1/2. So my R ends up being 1/2. Now, if you typed this in and put parentheses, or actually I think just do the fraction. I think you can just do the fraction 4 over 64. Fourth root of 4 fraction 64, it should spit out 1/2 for you in fractional form. I do believe it does that. Okay. But it's nice to simplify the fraction first if you can. So I'm going down by 1/2, so this is 32, this is 16, this is 8, and half of 8 is 4. Okay. So the arithmetic, same concepts as the arithmetic ones, but a little more difficult because we're involving multiplications and roots and stuff like that. Okay. Your turn, do those. And you can have a decimal for the first one, that's not a problem because you have a decimal in the problem. Okay, so let's do these. First one, once again, we have 12 blank, 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 0.75. So the first thing we need to do is figure out what our R is. How do we get from each one? So R is the fourth root, because I have 1, 2, 3, 4 of 0.75 divided by 12. And as we found, you cannot write 0.75 over 12 as a fraction using the fraction key, but you can do 0.75 divided by 12 using your division key and parentheses around that, and you get R is 0.5. Okay. And once again, it's okay to have a decimal because you have a decimal as part of the problem. Otherwise, you use fractions. So this is 6, this is 3, and this is 1.5. And then half of 1.5 is 0.75, so we're good on that. Now, this next one's a little goofy, and we need to talk about the answer. So we're going from -9, 1, 2, 3, -2304. And then we want to fill in the blanks. So first thing we need to do is we need to find R. R equals, once again, the fourth root, because of 1, 2, 3, 4 over of -2304 over -9. So -2304 divided by -9 is 256. The fourth root of 256 is 4. I'm good. Some days I'm just really good. No, I didn't. I got the 256 part, but I did not get the fourth root of 256. That I was trying to do in my head. I won't lie to you. I did do this division on my calculator. I did not take the fourth root of that on my calculator.
So you just take the root of how much space over it is?
Yeah. So if you're looking for 4 geometric means, you would be taking the fifth root. If you're looking for 6 geometric means, you would take the 7th root. And you can do that. I think all the problems basically are all 3. Because there's another way to find this one and then find those two. And it's by using the square root to find the geometric mean between two numbers. Okay. So then we do this. So, and this one, -9 times 4. So I get -36,
You can do the fourth root of that?
-144, and then times 4, -576. Now, something I want to talk about that hasn't come up yet with any of these problems. I am beginning and ending with a negative. I am making the assumption here that my R is +4. It is entirely possible that my R actually is -4. Because if I take -4 times itself 4 times, I get +256, which will work for this. It could be that. An even root can be positive or negative. An odd root is one or the other. An even root could be either one of them. So in theory, I could have, this could be 36, -144, 576, and that would work too. Doesn't really matter. You have to recognize that those are possibilities. You do not necessarily have to give me every one of those answers like that. But it could be changing sign every other term. And with it being negative, it's a very likely possibility that I'm going negative, positive, negative, positive. In theory, the same thing could happen here. This could be -0.5, which would give me -6, 3, -1.5. That would also work, would it not? And your book talks about this. I generally make the assumption that it's even. If you go with that, I'm okay with that. If you go with it as being an even number, so they're all positive number, not even, positive numbers. If they're all positive, if you leave your R as positive when you have a choice, I'm okay with that. Do remember that if you're looking for 4 geometric means and you're going to have one positive and one negative, that will be okay, and it will change every other sign. But if it comes up being positive 4 on your calculator, just go with 4. If it comes up positive, go with positive. If it comes up negative, go with negative. Just whatever your calculator tells you, I'm okay with that. But do recognize that either one of these technically are correct. And I did, like I said, I did want to point out either one of those technically are correct. I don't really care which one you use. Okay? Questions about that? Okay, this is where we're going to stop for today. This is a good stopping point for today because we're going to use this on the next one we do.